Good evening, 안녕하세요. This is Samin. I would like to present this presentation on sustainability and innovation in design and manufacturing of this study tour in South Korea 2025. It was coordinated and led by Professor Ismail Hidajin. Before I start, I would like to give thanks to our Professor Ismail for coordinating this tour, and also I would like to thank to our both Seoul and Ulsan tour guides. Why South Korea? I was very fascinated knowing about South Korea and their leadership in innovation and technology. They are now global leader in advanced manufacturing, smart cities, and hydrogen technology, which in my degree it's very important in electrical and electronics engineering degree. And also they're working on integration of sustainability in industries, and they're exposed to real world exposure to innovation and tradition, rich tradition. So in our first day, we visited Palace and also Temple. There was the 6th of July. We learned about some cultures, about their history, traditions, and religious background. And on the next day, on the 7th of July, we went to Assembly. We learned about the role in provisional assembly, which is local government in Korean governments. And we observed some regional policies aligned with the national priorities as well of the citizens of South Korea. We also engaged in discussion on sustainability and innovation as well. Next day, we went to aviation museum, which was insightful. It showed us about Korean aviation history besides the global history as well. This visit on 8th of July was very significant because it talked about smart city, which is very aligned with our study tour. In this tour, we learned about how Korea in Songo city, they're trying to make it a smart city for green and clean urban model. In this slide, we can see smart technologies used by IFS in the Songo city. It uses AI-based traffic control monitoring system. As you can see, there's object detection, likely using computer vision or air traffic management system that identifies tracks of individual vehicles, car ID numbers, etc. There are also measures the traffic flow condition to control the traffic control, and also possibly integrates the smart traffic lights and urban mobility data efficiently as well for safety purposes. So it's the type of intelligent transport system Songo Smart City uses to improve traffic management system. In this slide appears to be a 3D modeled, 3D illuminated city model, likely a conceptual or a scale model of an urban development project of IFES. On 9th of July, we visited Ajou University. We explored Korea's ancient history, from its early kingdoms and dynasties to the traditions of family and clan, naming that remain significant today. We also explored the following day as well. And on the following day, we also learned about the Korean charm, traditional Korean history, wartime stories, gaining insight into beliefs, resilience, and values that have shaped Korean identity. So together, this session gave us a deeper cultural understanding that enriched the rest of the journey. On 9th of July, we visited Samsung Innovation Museum. Here, we learned about history of electricity, lighting, and telecommunication through physics knowledge. Also explored the inventions that paved the way the modern electronics work. And then we moved to Samsung innovations since 1970s to this very day. Now it showed the role of innovation that shaped everyday life and global economy today. After visiting Samsung Innovation, we went to the Science Museum as well on the day. On the 11th of July, we visited SKKU, which is Advanced Institute of Nanotechnology University. We had a lecture that was presented by Professor Jung-seok Choi. He is a nanotechnology professor. In his lecture, he showed us how to convert carbon dioxide into chemicals or hydrocarbon fuels. It uses nanotechnology electrocatalysts. So in his project, Dr. Choi, he showed us 4 different types of projects, which is electrochemical carbon dioxide reduction, and photocatalysis for solar fuel, chlorinated organic pollutant degradation, and nanostructured catalysts. All these catalysts he's in his project for sustainability project. In his project, he harvesting ethylene and using carbon toxic gas in the air. Through the air, he's processing the DCA into electrochemically converting into CO2 and also fuel as well. So he showed us some different catalytic processes and capturing CO2 and hydrogen. Next up is Seoul Energy Dream Center, one of the most interesting and highlights of our study tour in South Korea. The goal of is energy independence and sustainability. It uses zero energy building technology that reduces energy demand by 7% by passive design strategy. The goal is independence, sustainability, minimize energy uses, and maximize renewables, and optimize building systems. Technology used in this building is nothing but external Venetian blinds, triple glazed windows, light wells for daylight, edged angled walls to control solar gain, artificial granite to reflect heat, insulation rock wool backbone. Now in this building, here is an active side of Dream Center Energy Design. The building uses an advanced ground source heat pump system connected to dozens of geothermal boreholes. It's tapping into Earth's stable underground temperature to heat or cool water efficiently. Heat pumps, exchangers, buffer tanks, and chiller work in a looped system to deliver temperature-controlled air and water across different zones. In this slide, we can see the core system components. Um, In this slide, we can see the core system components of waste heat recovery system, the air handling unit, humidifier, water purifier, fans, and cooling heating coils. How it works on process flow is a mid-term air, that's 20 degrees, that uses filters, reheat coil, and cooling coil, and heat recovery module. And that goes to fresh outdoor air, example 32 degrees, and that uses filter, cooling coil as well. And then there's exhaust air and supply air in the system. The sustainable impact energy efficiency reuses waste heat and avoids energy hungry compressors. Interqualities purifies and humidifies the air. Next up is MOSLab, and in this tour we learned about how biotechnology, sustainability, and smart design worked. This combined fused technology they used. The core innovation is using mass cultivated moss as a natural air filter, removing up to 90% of fine dust, 40% carbon dioxide, and 60% VOC, which is very toxic gas, without needing water, light, or soil for up to 12 months. It's a game changing for urban indoor environments and fantastic indoor air quality control system. As I spoke in the other slide, why moss removes pollutants and is very efficient. It doesn't require any light, endures no light for 12 months. Here you can see a video, and it's in work. There's different designs of product development for this technology as well. Next up, on 15th July, we visited Embassy and in the Motor Studio. In Embassy, we were introduced to an opportunity for diplomacy, innovation, education exchange inside between these two countries, Australia and South Korea. And in Hyundai Motor Studio in Goang, we explored hydrogen fuel cell system beside other system, like how different technologies in Hyundai is developing and through innovation. In Hyundai Motorsport Goang, we visited, and there's they showed this fuel cell technology in Hyundai. And in the Busan, there was a big, huge, significantly tour we had in Mexico, K-ICT Conference. With Professor I and a few other students visited many stalls, more than 20 plus. But the most highlighted one is I'll be looking at is the KIST, which is Korean Advanced Institute of Science and Technology. There are many different projects. One of the projects was AI, circulatory economy, airborne object and vessels, those kind of technology they have been working on. Another thing is very interesting one is nuclear modular, which is small modular reactors we visited. That is like suitable for smart cities. And next one is hydrogen pilot city, Ansan, and they're developing on this technology. So in this slide, you can see the hydrogen pilot city, the massive city, using the hydrogen fuel cells and hydrogen technology, and it's from production, distribution, and use. Next up, we visited on 18th of July the Hyundai Alsan plant tour in the museum. They showed us different cars and the history of it. Then after that, we went to the manufacturing of the plant where we saw the process of the car in the assembly line. Yeah, um, and then we visited on next day after the day off on Saturday. On Sunday, we went to Alsan Museum, explore further cultural heritage. And 21st July, we visited an important tour, also polypropylene, where we learned about how polypropylene is produced. So Alsan PP they use polymer array and SK advanced technologies, and they also have innovation sustainability projects. Um, in this also slides, the presenter showed us how polypropylene is produced and the process. This was our last day of industry visit on POSCO Steelworks and also POSTECH. POSCO is of manufacturing green steel and through innovation in heavy industry technologies. And POSTECH is a university industry collaboration where the startups incubator work on closely with the industry. Here's with few models of POSCO steels, and here's a POSTECH, and there's many different startup map you can see. And the POSTECH, they have many projects students working on closely with industry. So in the POSCO market is a think tank market where students work for the changed up grant POSTECH, and they get exposure to the cutting edge technology in science and engineering R&D. This is the end of our great adventure tour. It has been such an insightful tour for us engineering students. As an electrical engineering student, I got to see a lot of different aspects of technologies in South Korea that we can bring in our university as well for different projects. That's saying thanks for watching.